All right, everybody, check it out. We're going to go over the homework. What is the reciprocal of 5? Some people didn't know, right? What does reciprocal mean? It just means to flip the number. Well, if there's nothing to flip, you wouldn't know. But remember, all whole numbers are over 1. So the reciprocal of 5 over 1 is 1 over 5. Okay? What did this person do wrong? 6 and 5, 6 times 4 and 3/4. When you look at it, you'd say, well, this kid just did 6 times 4, which is 24. They did 5 times 3, which is 15. And 6 times 4, which is 24. They just multiplied 3 different numbers. And that's not how you would solve this problem, because as a whole, you're looking for 4 and 3/4 of this entire number, not just of part of it, right? So if I was going to do this problem perfectly, or the correct way, I would have to make the mixed numbers improper before I start. And you only do this when you multiply and divide, right? So this would be 36 plus 5, which would be 41/6, times 16 plus 3 is 19/4. Now this wouldn't be an easy problem because you can't cross simplify, but that's how you would solve the problem. All right, and if we are estimating, this is closer to 7, right? And this is closer to 5. 7 times 5 is, I'm going to get an answer closer to 35, not 24. Okay, so the thing they did wrong was they never made them improper. Okay, number 3, we're going to do the numerical part of the problem first. So let's look to, when I multiply, remember, I can look to cross simplify. 3 becomes 1, and 6 becomes 2. 3 goes into both, 1 and 2 times. So the numerical part of the problem is 1 times 1 is 1, and 2 times 4 is 8, right? And now, if I've got 5 t's on top and 1 t on the bottom, I'm going to have 1 t cancels. So I'm going to have 1 t to the 4th over 8, or just t to the 4th over 8. That is the best final answer because it's got the least amount of writing in it. Okay, number 4, I'm going to look at the diagonals. Nothing cancels. I know a negative times a negative is a positive. So let's just go right across. 5 times 1 is 5, and I have an x. 9 times 3 is 27, and I've got 2 x's, right? So if I actually wanted to expand it out to show you how the canceling works, I'd have x times x, right? And you can see that anything divided by itself is 1. When I put it back together again, I get 5 over 27x. That is the final answer. Okay, number 5, cross simplifying. 3 and 15 are going to become 1 and 5, right? 7 and 14 are going to become 1 and 2. So my numerical value is 2/5. Now, my variables, I've got 3 p's on top and 4 x's, and I've got 2 x's in the bottom and 1 p. So I'm going to ask you this question. Rather than list them out, where do I have more p's, in the top or bottom? I have more on the top. So how many more do I have on top? 2. Where do I have more x's? On the top. How many more? 2. So that would be your answer. 2p to the second x to the second over 5. And number 6, some people are going to be tricked by this because that's a whole number, it looks like, but all whole numbers are over 1, right? So since it's over 1, we can cross simplify here. 3 and 6 become a 1 and 2. And I get 5 over 2. And I've got f to the second on top and f on the bottom. Where do I have more f's? On the top. And I have 1 more on top. Okay? So instead of listing them out, I simplified on the diagonals this time. Now for the division problems. Remember, when you divide, that's the same thing as multiplying by the reciprocal. So we're going to rewrite these problems as multiplication problems. So we're going to flip it, and we are going to change that to multiply. Okay? And when I multiply, I remember that I could cross simplify. So that becomes a 1 and a 3. Okay, 5 goes into both, 1 and 3 times. And 3 goes into 3 and 12, 1 and 4 times. So now I go right across, just like multiplication. 4 times 1 is 4. 3 times 1 is 3. Okay, and I've got 3 p's on top, right? And 1 p on the bottom. So where do I have more p's? On the top, how many more? 2. So I wind up getting 4/3 p to the second. Okay, next one. Again, some people would be confused, but this is over 1, right? So first fraction does not change. Okay, we flip it, which is taking the reciprocal, right? And multiply. So let's do it. Cross simplify. 2 and 4 become 1 and 2. and I get 5 over 2. And where do I have more x's? I have 1 x on top and 3 on the bottom. I'm going to have 2 more x's in the bottom when I simplify. Okay, so that is that. Next one, 4 over x, or 4x to the third over 7k. And remember, dividing by a fraction is the same as multiplying by its reciprocal. So we flip it, and we change it to multiply. Okay, so here we go. 4 becomes 1, 16 becomes 4 because 4 goes into both. 7 and 21, 7 goes into both 1 and 3 times. So my numerical value, and I'm going to write down here, is 3/4. 1 times 3 is 3. 1 times 4 is 4. And now, let's look. I've got 1k, 2k's on top and 1k on the bottom, right? 2k's on top, 1k on the bottom. So where do I have more k's? I have 1 more k on top. X's. I have 3 x's in the numerator and 1 in the denominator. So where do I have more x's? On the top. How many more? 2. So there's your answer. 3k x to the second over 4. And this could confuse people because this looks like one big crazy long fraction. But remember, this is 3x over 4p to the second divided by, that's what this is, right? Divided by 6x to the third over p. So when we see it like that, we say, oh, okay. It's 3x over 4p to the second. Then I got to flip this guy, right? P over 6x to the third. And I flip it, and I switch it to multiplication. And here we go. I can cross simplify 1 and 2. So I wind up getting 1 over 4 times 2 is 8, 1/8. And I'd say p's. I'm going to simplify in the diagonal. I'm going to have 1 more p in the bottom. X's. I'm going to have 2 more x's in the bottom. So it looks like px to the second. And you could list them all out and cross them out to be absolutely certain, but that's how it would all work out. Okay, and that's how you do the homework, guys. Looks a little messy. This pen is a little tricky to write with, but that's what we're looking for, and that's the work that we need to see. Okay, good job, and hopefully we're getting better at the variables.